To begin, this is CICON. We're going to create a new project, and we'll be using the PLCS for this demonstration. So I'm just going to hit next and title it Webinar January. For developers, you can select the name that you want, the name of the project, and then the project path. So this is currently saving in my C drive under CIMON and then CICON Engineering. However, you can change that by pressing the project path and selecting where to upload and save this project. Additionally, if you would like to enable function block extension, that is possible. Just select this button here. However, I'm going to leave it disabled. And if you are using a hybrid, it uses the CM3 CPU types as well. But make sure you double check and click SHP07 for the newer hybrids or the HP07 for any legacy hybrids. And for this demonstration, I'm just using a normal CM3 PLCS, so I will not be selecting any of these. You can set a password for your project, so this will help you as a developer keeping your intellectual property safe and secure. We have additional security as well, so you can't do normal password as such as 1234. So if I was to hit OK, it is in violation. So here are the parameters. You can't use the same number or letter more than 4 times, 4 consecutive numbers such as 1234, or 4 consecutive characters such as ABCD. So those are the restrictions. Password mode and permission mode are for additional security as well. So if you select that to no, it will be in password mode. If you select yes, it'll be in permission mode. So I'm just going to select no, leave it in password. However, I'm not going to leave a password for this project. And you can also provide a description like that. So I'm going to hit OK. And then over here, we now have our project window. So under program, we can right click and then select new program. These are all the different types of programs that we are able to communicate with and put on our PLC. Some are reserved for CM1s or older PLC modules, such as like the DNP 3.0 and CIMON Net Master Slave. However, all these other options, such as PID control, HSC, or high speed counting, positioning, they're all for the PLCS. Up here is our main ladder diagram or ladder logic programmings. We have scans, subroutine, cold and hot start initialization, and periodic interrupts. If you select periodic interrupt, you can select the priority of the interruption. So the lower the number, the higher the priority. So if I select 100, is lower priority than 0. And then in milliseconds is how many times the program will interrupt. So I'm just going to start off with a normal scan program. I'm going to select the name as main, and its program ID is 0. I believe the maximum number is 111. I apologize. So you can have up to 112 scan programs, as seen here. So 0 through 111. I'm just going to do 0 and hit OK. This is our main scan program. Each program should have an end instruction and a p-end instruction to end the program. So if those are not included and you're experiencing any errors, make sure that your programs end with end and p-end. And if the instruction program itself doesn't require an end, it will definitely require a p-end. So if this is somehow deleted, make sure to add that. I can show you how to add that momentarily through the ladder logic examples, but what I'm going to do now is add some more rungs. So when I'm adding a rung, it's going to add it above the rung that I have selected. And to do that, I'm just going to press Control and L. So Control L will add a new rung each time that the button is pressed. And we can see that unsaved rungs or any rungs that have any kind of edits made to them will appear as this bluish hue. This is signifying, again, we have a change made to our program, along with this asterisk up here for the program itself. And these red lines indicate that the rungs are invalid or incomplete. So if I was to save this with Control S, they will go away. However, if I was to add an open contact by pressing this button here or pressing F5 on my keyboard and typing M and 00, that the rung is now incomplete. So if I was to save it, we have an incomplete rung found. Do you want to delete it? We can see that it doesn't fully save. I can add a coil with F9 or this coil option here, and I can do Y00. So we can see we have an unsaved rung here. However, it is now a valid rung shown in green. If I was to save it, we can see that it saves and fully compiles. Our data registers for our contacts are just bits, as every other program is. And we can identify that with the dot operator right here, or the little period. To enable the period, it's not enabled by default. So I'm going to go to Tool, Options. I'm going to go to LD Editor and allow dots for device input and check that. Hit OK and reload the program, and then it will be easier to see that the word comes on the left and that the bit itself is on the right. So I'm targeting word 0 and the first bit or the 0th bit. Same for our outputs with Y00 or our coils. To download this to my PLC, I'm going to go to Online and Connect option. I'm going to select USB since I'm doing this over USB Mini B. However, we have all these other options such as Ethernet, serial, lease line, dial-up, simulator. I'm going to hit OK. And I will now do link, download, and monitor. This is going to download the program to the PLC. Additionally, you can hit this button here, which I will do. For the rest of these messages, you can just skip through them. They all are just notices. So I'm just going to hit yes. I'm going to hit OK. This tells us the step size or the amount of memory that the program itself takes up. We can see that we allow for just a little over 10,000 on this specific PLC. So my program's taking up 25, where I have 10,215 remaining. If I don't want to include any comments or variables or function blocks, I can just select these here. But I'm going to hit OK. And let it download. And then I'm just going to hit yes. And we can see with this watermark up here where it says run, we are successfully connected to the PLC. Additionally, any variables that have or data registers that have any numbers will show a 0 if they are not latched or set by default. And then, okay, so we are fully connected to the PLC. And to interact with contacts or coils, we actually can do that as shown here. So I'm going to left click on the open contact, and I'm going to press Shift and Enter. So holding Shift and pressing Enter will allow me to energize the coil and the contact, shown by that blue button. So it is on, therefore my coil is on. We also have online editing available, so without having to re-download all of that program and sit through there waiting for the program to download to the PLC, we can select the pickaxe, and then here I can do another open contact. So I'm just going to do M0A, and then now I'm going to actually do an instruction. So if we select uh, F10 on the keyboard or type an instruction such as add, which I'm doing just by typing on the keyboard. As you can see here, anything that you type will show up, like keyboard, if the K showed up. However, I'm going to do add. Add takes 3 data registers. It's going to add S1, S2, and save it into D. Up here in the top, I'm going to just do D0, D1, and D2. Otherwise, you can select the data registers here manually. So all of our data registers are available as input parameters, while only a few are available for our output parameter. So I'm just using single word data registers to do an add instruction. And then to download this change to my program while the PLC is running, I'm just going to hit online edit download. So as we can see that this saved the change from before of where I was enabling and disabling the contact or providing it energy and power. Otherwise here, I can change these numbers by either by doing shift enter. So if I hover over the instruction, press shift enter, I can do 1 plus 1, and that will save into D2. So the instruction itself is not executing since this contact is not on. But if I was to press shift enter on the contact, we can see that 1 plus 1 is saved into D2. And if I want to change any of these numbers again, I can do 20 plus 20, which should be 40. And since this contact is on all the time, it will then change to 40. We offer additional instructions to prevent this just in case. So if I change the add to add P, this will change to a pulse instruction. So we'll only energize once the pulse is changed. So if I change it to just 1 plus 1 again, we can see that it is not executing until I re-energize it. Otherwise, if we wanted to do just F7 or a positive transition sensing contact, I can do that by doing this, changing this to add D3, D4, and save it into D5. And then I will change these numbers to 1 and 2. And we can see that it only does this once. So even if I change it from 10 to 11 to get 21, I have to re-energize it. You can also use the same data registers over. So if I wanted to do this, I'd do D3 plus D4 and save that into D4. I can do 1 and 1, and this should be a simple incrementing counter. And we do offer other instructions as well that can actually do what I was just doing with increasing. So I can do D-inc D4. And this will accomplish the same effect. In terms of data registers, if you wanted to work with B words, we do offer those instructions as well. So certain instructions such as adding or multiplying, subtracting, and whatnot, you can just put a D in front of that for a D word add. However, I'm going to change this to D0, D2, and D4. So the double word D0 is going to occupy D0 and D1. D2 will occupy D2 and D3, and the double word will be saved into D4 and D5. So if I change these values here to 1 and 1, we can see, I'm going to actually delete this instruction here since it's conflicting. We can see that it works the same way. However, I can expand the range and go above the limit of our data registers that we allow. So I will do 32,767, which is the maximum number allowed for a word, which is just 2 to the 16. And I will add 1 to it, which will then carry over and not overflow back to a negative value. It will rather stay this 32,000. And if we wanted to actually see this, we can select the memory monitor right here, this memory monitor icon, or we could go to online and select memory monitor. This will allow us to visually see the binary representation of the changes that we're making to our program. So I'm actually going to close out of this so I can put them side by side. Move that there and then reopen this. Okay, so we can see that M00 is energized here. So I'm going to left click and select MDev for the M device. And we'll move this or shrink this. We can see that if I change the value to off, it changes here respectively in the data register or in the memory monitor itself. Same for the A, as well as the B, which I had deleted. But if I want to just change that, I can select B by double clicking it and changing its value to 0. And its respective decimal, hex value, and ASCII characters change when the number itself changes. So if I was to change this .A to a 0, we can see that we have just 1 in the data register. If I wanted to do 500, the respective bits will change. We can also organize them by ascending or descending. So F through 0 or 0 through F. If I go over to the D device, we can see we have the full word for each data register here. But if we want to view them individually, we can just select the D device bit. And now we can see D00, which is that 32,767 is right here. And our sum is here in the D04. If I change any value here, we can see that D0 itself changes since D0 and D1 are occupied as a double word. Same goes for D2 and D3. And then the sum itself is saved in D4 and D5. So using this, it allows us to have an additional 2 billion signed or unsigned, or 4 billion unsigned option. To change that up here, we can see that these are unsigned as there is no plus or minus in front of them. So if I was to put -1, we can see we have the maximum unsigned value. But if I change the display right here, we now will show -1 and -32,768 shows there. I will do that. So now we can change the display again. We have our unsigned values or our hexadecimal values. So CICON offers unsigned, signed, and hexadecimal. For a full list of instructions, we can go to Help and select PLC instructions and Basic or Application. So I'm going to select Application. Here we have our arithmetic and comparison. Those are probably the most two important ones, and each individual instruction here. This help file is a little bit dated, so I would like to quickly take a moment to display the current help file that me and a few others are working on here, which is our online version of this. And usually when I show this, I get some questions about it afterwards. So if anybody would like me to display any pages for them and send them individually, I can do that. However, this link itself, as shown here by localhost, is not live. But if we go to instructions and application, we can see the addition instructions are a lot more organized than this, where we have just a few information in words. Here in the online help file, we have our operands or our inputs, as I've shown before. So this would be D0, D1, and D2. We can see that the add instruction is only word based. So this is our maximum range. And then we have notices just in case any errors occur. And then we have some nice examples just to show how all of the instructions work. So if anybody would like any page directly from this help file, I can definitely do that and email you. So just let me know. But we are hopefully going to be done with this help file soon, which will include a lot of information that I'll be covering here and additional information such as Modbus and whatnot. So back to CICON, we've seen basic inputs and outputs and instructions. Next thing I want to show is some logic gates, which is possible. So I'm going to be again using the M data registers. I will do M1, and then I'm going to do just another increase instruction. I'll be using D10. And then I'm going to make an AND statement here. So while M1 is on and M1.1 is on, increase the data register D10 only by 1 pulse. So as we can see that this value is 0, if I was to energize M1, nothing happens. But again, if I was to energize M1.1, we then increase it. So it will not increase either way until both coils are on, or contacts are on. That is an AND. You can add as many ANDs as you would like into this, as shown by me inserting the contact anywhere. If you want to do an OR, all you have to do is just add a contact below, select the rung above, and press this insert vertical line, or you can do Shift and F2. So we can see that the line changes from invalid to valid and connects there. If I leave it invalid and try and download, it says an error was found in some rung. But if I connect it and download, we should be good. So now energizing either contact will increase the data register, and both at the same time will work. So if both are energized, they should increase. So those are our basic logic gates. The next thing I would like to show is the variable editor. So if we go to view and select variable editor, this is how we can apply descriptions and comments to each variable or data register that shows up. So if I was to select D word, for example, and select all var, we can now edit the variables and descriptions for each data register. So D4 is the sum, while D0 and D2 are our operands. So we can do input 1 is a description and input 2 and save the sum. So these are just some comments that we can see here on the rung itself. If we select just device only, the comments will disappear. If we select device and variable, we will see the D00 and any variable name. So if I change this to sum, we can now see the variable name here. And I will just change the description to make it easier. And we can select just comment. So that sum of here never appears, but the comment of sum D0 plus D2 appears, or we can show both. And the variable name will come after or before the comment. So I usually leave it as just comment. The variable names themselves can be used in the ladder. So I will demonstrate that here. I just do a new instruction, for example, um, I just do sub, for example, and I want to do sum minus D2 and save that into D6. I can plug sum in here, which is the name of our variable, and it recognizes that D4 is sum. So I don't have to specify D4 in the instruction itself. And then it will appear like that. The data register itself will appear rather than the variable name to be consistent with the rest of the instruction and other remaining instructions in your ladder logic. But if you'd like to use the variable name, that is how you can do that. And then each additional bit or word for all of our data registers can be selected and commented. Our F bits and F words are internal relay flags, so we recommend not touching these at all. Rather than editing them, they can be used in the ladder. So, for example, I will show that adding some more rungs, and I will do an open contact of F93 and do P D7. So every 1 second, the data register D7 should increase. And that is happening because I am using this clock right here, F93. So to focus more on the PLC side of things rather than the ladder logic, we can see that my current chassis includes the CPU, an input and output module, just an output module, a EAA or analog to digital, digital to analog combo module, and an RTD or channel module. Those are displayed each time you connect to the PLC. So if you were to press this icon here or connect before link download monitor, it will then display the chassis here. To change the IP of the PLC, you can select PLC parameter by double clicking and going to Ethernet and changing the IP address, subnet mask, and gateway. Those are options here. But each time you do change it and you re-download, just know that if it is plugged in to the network, changes will be made. In the PLC parameters, you can change the timing variable. So in here, we have 100 millisecond timer variables, which go between T0 and T127 by default, or you can change them. And the 10 millisecond timer variables will then change in correspondence. You can enable the watchdog timer and set its period for watchdog timing. And you can treat the watchdog timer CPU error as well. Latching our K variables as shown here, K bits and K words are latched by default. However, if you want to make specific variables latch, so I'm going to make the M's, you just select the variable itself. And when it grays out, they're not latched. And if I was to do this, I want to do M through M10, M0 through M10. This means that if I was to disconnect power from the PLC, then the M0s through M10 should remain on. So if I was to turn off the PLC, we can see that those D variables are reset to 0. Actually, I will do a D word, an M word instead for a better example. So I will change this to M5. Oh, M's can't be used, I apologize. Let me use a better example, I apologize. I'll latch D0 through D. Okay. And then if I was to just ignore this, do n plus 10, power that on, and then the PLC turns off. It is not working. Let me double check. I might have to re-download this. Let me re-download this to the PLC. Okay, so now our variables are selected. If I turn the PLC power off, there we go. We can see that the D10 is still 0, but D0, D2, and D4, since they are in range of the latch from D0 to D10, they retain their memory. So I have latched it or I have set it to non-volatile memory. So I'm just going to turn that off by default. This is our interrupt programs. If for any programs that we have by creating a new program, which can't be added during run, they will display here. CPU error. So if you have an analog module and are using the to and from instructions and the buffer memory is incorrect, it will pop up with an error, but you can disable that by selecting this. This is channel 1 for the PLC and channel 2 for serial for both of them. These are our inputs, any Modbus data registers here, and again, our Ethernet settings there. Additionally, you might have noticed that if I hover over a contact or coil or an instruction, it will give us the Modbus address. By default, this isn't enabled, so I will go to Tool, Options, LD Editor, and then Show Modbus Tooltip. Select that and restart the program. This will allow you to hover over and have the Modbus address directly rather than having to guess or do the mathematical conversion. To interact with an expansion module over here in card properties, you can double click on it. So I'm going to double click on the analog module. And here we can see that the channel is enabled. So I can go to status and let me just mess around with the training kit I have down here. Do an enable. So I'm going to select DA out enable. Hit OK. And now we can see as I change our analog value, it will change up top and be output. However, the output is not showing here since there's nowhere to display an output. So for any module that you would like to interact with on your chassis, you can do so by just double clicking and finding its information as such here. For buffer memory, if you want to interact with that, again, we can go back to the help file and then we can select CM3. I will go to the EAA, for example, and buffer memory. So if you want the output values, you can interact with 26 and 27 as the offset. So I can use the to and from instruction as shown here and interact with the buffer memory like that. However, again, that is still confusing. So if I do buffer memory and do read from, this will be a better example once the images are included on how to actually interact with buffer memory. And then we can see for our modules and analog. The buffer memory table has been converted, but includes a lot more information. So again, if you want the output values, this will explain everything here. The last thing I would like to go over is just the special programs that we can do. So for example, I'm going to just make a high-speed counting program. Each individual program will show up here in the project tree on the left, and if you'd like to navigate to it, you can do so by selecting it in the option menu here. While the PLC is off, that error shows up that all values are 0, which is true since, again, the PLC is off rather than the latch data. Positioning, I'll include as well. Some important information is the start address of each special program might begin at a certain data register set, and each special program can take a certain amount of words in their memory to function. So if we go back to the help file and go to high speed counter, for example, we can see that the high speed counter takes up to 52 different words for channel 1 and channel 2. So channel 1 will take up to 26, starting at 0 and ending at 25, while channel 2 takes 26 as well, beginning at 26 and ending at 51. So we know that if we begin our high-speed counting program at D0, that the maximum number that we can use is D51. Therefore, if we were to do any instruction between D0 and D51, it will overlap with our high-speed counting program. So that's why I usually will just change the starting register off by 100. The channel itself can be selected, so 1 or 2, and we can see the corresponding data register changing. So I'm just going to enable count. If that is not enabled for high-speed counting, then it will not actually work. It will still high-speed count, but nothing will appear. Positioning, same concept. We go to positioning and we do operation data. We can see that these registers are used for moving a motor on the X or Y axis, while in sorry, trying to find the correct link. In parameter, we use all of these different offsets as well. So positioning uses a bunch of different data registers. So I would start that at D200. X's and Y's can be monitored for channel 1 as well as channel 2. And a monitor menu will appear if I make this online. And we can then interact with a positioning program or motor here for the X and Y axis. However, again, this is just a basic CICON webinar, so I'm not going to go over high-speed counting and positioning in depth, but that's what happens when you add them as specific programs. So that will conclude this webinar. Again, it was just to go over some basic CICON information. I will remain in here for about 10 minutes. If you have any remaining questions, please let me know and I will answer. But thank you guys for attending, and I hope you all have a great day.